Hey everyone, speaking with us today is Dr. Alex Abramson, an assistant professor in the Chemical and Biomolecular Engineering department at Georgia Tech, who was featured on the Forbes 30 Under 30 Science list and the MIT Technology Review Innovators Under 35 list. Professor Abramson, would you like to tell us a bit more about your background and research?
Sure. Hello, everybody. Thanks for that kind introduction. My name is Alex Abramson, and as was mentioned, I am an assistant professor at Stanford Institute of Technology in the Department of Chemical and Biomolecular Engineering. I am also an affiliate in the bioengineering department as well. And so I have a slide that I can share. I did my PhD at MIT and my postdoc at Stanford. My lab develops ingestible, implantable, and wearable robotic therapeutic devices. And specifically, we focus on improving patient adherence to different drug regimens. We also work on creating therapy automation, meaning creating new types of sensors and drug delivery devices that automate the process of taking your drugs, and also facilitating preclinical drug screenings for chronic diseases, such as diabetes, heart failure, and cancer. And so they were creating new tools for scientists to be able to screen drugs more quickly and get drugs from the bench to the clinic as fast as possible. So some of the things that we've created in the past have been pills that allow for the oral delivery of insulin and other drugs that need to be traditionally injected, as well as sensors that are able to detect whether or not a cancer therapy is working in a model in real time, rather than taking weeks to read out traditionally. Yeah, thank you so much for having me.
Hi, Mr. Abramson. Thank you so much for talking about your work. So we'll move on to the Q&A section. So for our first question, what was your inspiration behind being a STEM mentor for local students?
Yeah, so it's something that I've always really enjoyed doing, being a STEM mentor. I started off as a graduate student, being a mentor to undergraduates who were in my lab, and I also was very involved in the local community as well, working at elementary and middle schools to make sure that students who were working in these areas of STEM and were interested in that area to understand what it really meant to do research and how the things that people were learning in class could be applicable to everyday problems.
Moving on to you as a person, what drives your work at the Abramson Lab?
So what drives me personally is to try and create new technologies that improve patients' lives worldwide. And specifically, I don't just want to improve their lives, but I want to extend their lives. And I want to make that time that they're on the planet have a higher quality as well. And so what we do is we create technologies that make it easier for patients to take their medications. And if it's easier for a patient to take their medication, it means they're also more likely to take it. And so medication will only work if you ingest it or you take it into your body. And so that's really the main goal of a lot of our research, is trying to make it so that if a patient's taking their drugs, it doesn't have any sort of off-target side effects that cause a person to not feel so great whenever they take it, and to make it easier for them.
And getting more into depth, how do you think bioelectronic therapeutics will transform the future of healthcare?
Yeah, so I think that there's a huge revolution going on in the field of drug delivery right now. And it's in this area of bioelectronic therapeutics. As we move towards the future where we carry around our electronic devices, eventually we won't just be carrying them around in our pockets, we'll be carrying them around on our bodies, meaning that we'll be able to take pills that will tell us whether or not we're healthy. We'll be able to wear patches on our skin that will tell us whether or not we're healthy. And additionally, those pills and patches that are sensing the health conditions of our body will be able to then trigger drug delivery systems inside of our body as well to give treatments whenever we think that we need them. And so what you can imagine right now is you might feel a symptom and you then have to take a drug after you start feeling that symptom. But if we have sensors on our bodies, those sensors will preemptively tell us when we're about to feel sick, and they'll automatically start delivering the drugs, so we don't need to worry about it.
So what's your process in developing bioelectronic therapeutics?
One of the things that's really important is to choose a problem that is going to have a major impact on healthcare. And so I only work on areas where I know that if I create a new device, it's going to change patients' lives. And so it's very important to specifically pick that problem. And once I pick the problem, I don't already have a solution in mind, but I go through some design thinking principles to understand what is the best possible solution for that problem. And so what we do is we create a set of roadblocks as we try and solve that problem. And we generate a bunch of solutions for each one of those potential roadblocks. And we do that in a multidisciplinary manner. So it's not just chemical engineers who are coming up with those potential solutions, but we bring in mechanical engineers, electrical engineers, biologists, and healthcare professionals. Everybody's coming up with different types of ideas. And then together we decide which ones are the most feasible. And we put those at the top of the list. And we tried those particular solutions. The other thing that's really important in the process is not just developing a device totally on its own, but understanding how that device is going to interact with the body. And so we use different types of models and tissues that we can collect in order to make sure that the devices that we're making are interacting with the body in the appropriate manner.
So are there any certain challenges that have come up when you've been developing these devices?
There's a lot of challenges. One of the biggest challenges is making sure that your device has a proper interaction with the tissue. And so what that means is that if it needs to attach to the tissue, we want to make sure that it first reaches the tissue, and second, that it adheres to the tissue for the period of time that we want it to adhere for. And there's different solutions to that. You can use chemicals and hydrogels that adhere to the tissue, similarly to tape, right? You can use physical solutions like a clamp that will allow you to adhere to the tissue, or you can use a combination of the two of them. And so that has been one of the biggest challenges, is understanding how to get these devices to autonomously attach to the tissue without us having an actual hand on the device at a specific time.
That sounds very interesting. So how do hydrogels specifically connect to your work?
Yeah, so we use hydrogels in a couple of different ways. One of the ways that we use hydrogels is that we load drugs into them. And depending on the hydrogel formulation that you make, the drugs will elute from that hydrogel over a long period of time or a short period of time. And so if you deliver a hydrogel that's loaded with drug, you can then get a specific release profile of that drug and make it last longer than it would traditionally. Another way that we use hydrogels is as a component of our device. And so that might be using it to expand. And if it expands, we can make it move something on the device. We can also use hydrogels to adhere to tissue. So you can create bonds between the hydrogel and the tissue itself. And so that creates an adhesive bond. So those are some of the different ways that we use hydrogels.
So moving on from the technical parts of your career, what kind of advice would you give yourself early in your career?
So one thing that I think is important is to try lots of different careers because especially as you're in school, you don't really have the exposure to a lot of the different options of what it means to be in a specific career. And so what I did is I actually tried a lot of different jobs. And even when I knew that I wanted to do research, I tried a lot of different research opportunities. So I didn't know from the first day of high school, or even the first day of college, even the first day of graduate school, that I wanted to be a professor. I figured that out along the way. And so in college, I picked a major that allowed me to go into pretty much anything that I wanted to, and that was chemical engineering. So I learned a lot of biology, I learned a lot of physics, I learned a lot of math. And so that allowed me to go really into any direction that I wanted to. But when I was there, I realized that I really enjoyed research. So that was the career path that I pursued.
So you mentioned that after working in many different fields, you eventually stumbled upon your favorite like thing to do, which was research. So how could high school students get involved with research involving robotics and healthcare?
Yeah. So one of the things that's really easy to do in high school is to just build devices on your own, right? It's very easy to buy Arduinos and to get things 3D printed and work in AutoCAD. So these are things that are all available at a really cheap price. And so just, experimenting on your own with building different things, I think is really important. If you wanted to get into biomedical research specifically, I'm sure that there are a lot of summer opportunities at different universities around the country that students could benefit from. I know that in the labs that I worked in the past, we had high school students in the summer. And that gives you an introduction into what it means to do research. But I think that really at the college level is when a lot of people understand what it means to do research and can spend an extended period of time actually building.
What were some discoveries that helped you create your designs and in robotics and healthcare?
Yeah, so probably the most exciting thing that's happened to me during my research career has been getting some of the devices that I've worked on into clinical trials. And so the pills that are able to deliver insulin and other macromolecules orally, those are currently in clinical trials, and those clinical trials are sponsored by Novo Nordisk. And so one of the things that has gotten me to that point was doing a lot of testing in the lab. And so it's hard to say a very specific problem that got me to the point of getting into clinical trials. There were probably hundreds of problems that were associated with this particular pill, and I had to go through it. Each one you have to make sure that you work on with a real sense of diligence to make sure that the experiments that you're performing are testing the specific problems that you have. But getting something into clinical trials was incredibly exciting. It's definitely one of the highlights.
Well, everyone, thank you so much for watching our interview with Professor Abramson. Take care and we'll see you all next time.